Yeah, hello everyone, myself Maruthi, welcome you all to this physics video session. Right, in this video I have taken a topic from chemical bonding dealing with aluminium trichloride. Alright, so as you all know, few elements in the periodic table are out of the 118, few are inert. They are stable, their outermost orbital is completely filled. Whereas few elements in the periodic table or in the nature, they are not stable. The reason, their outermost orbit is not completely filled. They don't have octet configuration. They don't have 8 electrons in the outermost orbit. Alright, so that is the reason that few elements like to lose, gain electrons so that they too can behave like the inerts. Alright, we know inerts are very inactive. Why? Because they are stable. Right. So now the process of losing or gaining electrons to get stability, the chemical activity involved is nothing but the chemical bonding. Right. So there are many types of chemical bonding. At the foremost and the very important is nothing but ionic bond. So ionic bond is a bond which takes place by the complete transfer of two atoms or ions or whatever. Right, but complete transfers of electrons between two atoms or between two ions. Right, but the electrostatic force, right, holds the two atoms together. We have to remember that. So let me explain you with the help of an example, that is aluminium trichloride. So before going to that, this is the concept which says the electrostatic force of attraction between the cations and the anions. Cations are nothing but the positive, anions are nothing but the negative. The force of attraction which holds two atoms between together, right, is nothing but the ionic bond. Of course, you have to remember, cation is a positive charge, anion is a negative charge. But when after combining together and forming as a compound, it's neutral, it doesn't have any charge. So that's what he says, newly chemical atom is called ionic bond. Now the example, as I said, aluminium trichloride. So what are involved in the formation of aluminium chloride? Trichloride is nothing but aluminium plus 3 chlorine atoms combined together will be having aluminium trichloride. Right, but what I said to you just now, ionic bond is between the cation and the anion. Out of these two, which is anion and which is cation, let's work on that. So let's work on the formation of cation. Right, cation formation, alcl3 plus. Okay, now what is the one what we have taken? It's nothing but the aluminium. Right, aluminium, right, atomic number, we are talking about aluminium atom here. The atomic number of aluminium atom is nothing but 13. How many protons are there? It doesn't mean. So as we are saying atomic number 13, we can say that number of protons are 13 there. Now the electronic configuration, 1s2 means in the first orbit we place 2 electrons, 1s2. 2s2 2p6 means in the second orbit, that is nothing but the L orbit, we have placed right 2s2 2p6. 2s2 2p6 we have placed 8 electrons, and as we are saying 13, 2 are adjusted in the K, right, 8 are adjusted in the L. Now K, L and M, 3 electrons are there. Alright, that's what I am saying. In the first orbit 2 electrons are there, in the second orbit 8 are there, in the third orbit 3 electrons are there. But if you talk about the inert gas electronic configuration, means till where which inert gas has completely filled till now, till we reach aluminium, which is the nearby inert or which is already filled, is nothing but the neon. Neon atomic number 10, which is already filled. Means if we come till neon, what does it mean? First orbit and second orbit are completely filled there. So neon 3s2 3p1. So by this we can say that the 2 orbits are completely filled, and the third orbit we are having 3 electrons. So the last orbit, third orbit is having 3 electrons. So what does it mean? The number of valence electrons are nothing but 3, means outermost orbital is having 3 electrons. But as you all know, right, outermost orbit should have 8 electrons. Then only we can say it is completely filled. If it is having octet configuration or ns2 np6 configuration, or if it is having 8 electrons, in a simple way we can say the atom or the element is stable there. But as you have seen, it is having only 3 electrons. Fine. So do you think it is stable? No. Why? Why? Because outermost orbital is not completely filled. So Aluminium is not stable. But please remember, aluminium atom is not stable. Just you have to remember that. Now, as it is not stable, it wants to become stable. That's true, right? But before getting into that one, we have to discover the charge of the aluminium atom. So charge here, number of protons are 13 and number of electrons are also 13. As equal number of protons and electrons are there, the charge is neutral. That's cool. That's good. Now let us go to the concept symbol. What is the symbol of aluminium atom? So it's nothing but Al. That's fine. But if we are asked to find the Lewis dot picture, as we all know, Lewis dot picture, right? The inner orbits, right, and here right, the number of protons and the inner orbit electrons all are placed in the form of the symbol. Now the valence electrons, the 3 valence electrons are represented with the help of dots around that 1, 2 and 3. So the symbol is representing the kernel. Kernel means all the 13 protons and all the inner orbit electrons except the valence, all the 10 electrons are represented by the symbol itself. That's what Mr. Lewis said. Right. So by seeing this one straight away, we can say that it is surrounded by 3 dots, means the valence electrons are 3. Right, that's the concept. So aluminium atom, valence electrons are 3, but it is not stable as outermost orbital is not completely filled. Then what does it do? Right, to get stability, right, it is having 3 electrons in the outermost. What shall it do? Simple answer. It can't get 5 more. Alright, 3 plus 5 is 8. It can't get 5 more. Simple logic, let it lose 3 electrons. The outermost orbital, which is having 3 electrons, that will be lost by aluminium atom. Why it is doing that? Simply to get stability. Stability like nearby inerts. So who is nearby inert? Just now I said, if it loses these 3 electrons, it's already 2 orbits are completely filled. So aluminium also behaves like the nearby inert neon if it loses the last 3 electrons. So it loses. How many? So 3 electrons to get octet. 3 loses 3 electrons to get the octet configuration. So if you go for that one, so it's nothing but, right, of course, the atomic number still be 13, right? The outermost orbit will be removed. These 3 electrons will be removed. So now it is having 1s2, 2s2 and 2p6. What about the remaining all? They are released, they are lost. It is losing 3 electrons. Right, now if you check it out, shall I say it is exactly the inert gas electronic configuration, right? It is like neon. Yes. Now, if you think about the first orbit is having 2 and the second orbit is having 8. Right. Now, which become the outermost? The second orbit became the outermost, K and L. But now in the outermost orbit, how many electrons are there? 8. How many valence electrons? 8. Means is it stable? Yeah, it's nothing but stable there. Fine. We got stability. But what about the charge? What about the symbol? What kind of? Is it an atom or it is an ion? Now if you check that one, let's see the number of protons and electrons. Number of protons are 13 still, whereas number of electrons are only 10. They both are not equal. If they are not equal, please remember, it can't be called it as an atom. It's nothing but an ion. So what kind of ion? Is it a positive ion or a negative ion? Depends which kind of particles are more. Negatively charged particles, if they are more, we say it is an anion. If positive charged particles are more, we call it as cation. So if you check it out, 13 protons, 10 electrons, means protons are more. How many more they are? If you check it out, it's nothing but 3 more are there. So can we call it as a neutral? No, it is negative charged particle. Which are more? Protons are more, therefore positive charged particle. It's a charged particle. Now what's the symbol? So it's nothing but obviously aluminium, right? But how many more electrons are there? It's nothing but it is represented by 3 plus, saying that it is having 3 protons more. How many protons are more? 3 protons are more. Now, here aluminium atom is neutral, whereas aluminium ion is not neutral, it's a positive charged particle. So what is that positive charged particle called as? It's nothing but cation. So we are all set with formation of aluminium cation, Al3+. To explain the process, I can explain you like this. Aluminium releasing 3 electrons or losing 3 electrons and becoming aluminium 3+, which is nothing but a cation, whereas aluminium is nothing but a neutral atom. These are nothing but the lost electrons. So we are ready with the formation of cation, Al3+. But the process is, right, aluminium trichloride. So aluminium is ready to give 3 electrons. So who are taking that? Let's watch. Yeah, now let's come to the formation of chloride. So it's nothing but anion. So what we are taking? We are taking chlorine atom. So if you take the chlorine atom, right, atomic number of chlorine atom is 17. That's cool. Right, if you fill the electrons in a systematic order or in the distribution of the electrons in the orbits and the orbitals, it's nothing but the electronic configuration. So let's distribute it. So out of the 17 electrons, I like to place 2 electrons in the first orbit, K, fine, and I like to place 8 electrons in the second orbit, L, right, and the leftover 5 I like to place in the third orbit. Right, so it's nothing but 7. 2, 8 and 7. Right, the electronic configuration there. First orbit is filled with the 2. Right, second orbit is filled with the 8 and the third orbit is filled with the 7. Cool. The total 17 we have distributed like this. Now, so if you check it out, first orbit is completely filled, means till neon, till helium we have reached. Second orbit is completely filled as it is having 8 electrons. So till neon it has reached. So if you talk about the inert gas electronic configuration, as we have reached till second one, that is neon, you can label it as, yes, neon 3s2 3p6. This we can call it as the inert gas electronic configuration. Cool. Now let's see the outermost orbit. Right. So the outermost orbit is having 7 electrons. So we can say that valence electrons are nothing but 7. Fine. Now, is it stable? If it has 7 electrons in the outermost orbit, is it stable? It's a known fact, right? It's nothing but the magic rule, octet rule, right? It should have 8 electrons to get stability, right? So, how many electrons is chlorine short by? It is short by 1 electron. It is also already having 7. It is running short by only 1 electron. So, if it gets that 1 electron, chlorine also will behave like a stable one, which is the nearby inert. So, obviously we know the nearby inert for the chlorine is nothing but argon. So, chlorine requires 1 electron. It wants to gain 1 electron to behave like the nearby inert, which is nothing but argon. So, that what it does, it wants to lose 1 electron. Why? Because it's not stable. To become stability, it has to gain 1 electron. That's what we say. Chlorine, right, outermost orbit is not completely filled. Therefore, it is not stable. To make you clear, understand, I am taking the chlorine, right? How many electrons are in the outermost? 7. So, 1, 2, 3, 4, 5, 6, 7. Lewis dot picture, right? Lewis dot picture is the best example to say how the valence electrons are. Why? What about the innermost orbits and the electrons and the protons? Of course, we know, as Mr. Kennel of this well, right? Lewis has said all those are nothing but the inside the symbol, right? Cl itself denoting everyone. So by clearly we can say it is nothing but 7 electrons. So it is running short by 1 electron. So what does it do? It gains 1 electron. If it gains 1 electron, right, that gets into the outermost orbit, now it is becoming neon, right, 3s2 3p6. Right, if it is neon 3s2 3p6, just we can say the last remote orbit is also having ns2 np6 electronic configuration, which is nothing but stable. So till second it's already filled. Now the third one is also filled. Now straight away I can say yes, it is behaving like argon. Right, when it gains 1 electron from the outermost orbit, that's what gains electron to get outer electron octet configuration. It gains 1 electron to get octet configuration. So then obviously we can say, right, it's the outermost orbit. Now it is having 8 electrons. Right, if it is having 8 electrons here, right, it's nothing but, if you like to fill it up, 2 comma, it's nothing but 2 comma 8 comma 8. Right, so of course please remember the atomic number stays the same, 17. The electronic configuration the same thing, 1s2, 2s2, 2p6 and 3s2, 3p6. Right, so atomy, right, it's chlorine itself. Right, but it is having 18 electrons. Now can you call it as chlorine atom? No, it's nothing but chloride ion. The reason is, people, they don't have, it has 18 electrons, whereas it has only 17 protons. So it is not an atom, it's nothing but ion. So which is more? Right, electrons are more. Therefore, we can say it as chloride, Cl minus ion. Right, of course it's not neutrally. Which is more? Electrons are more, means negatively charged. Negative charge. That's cool. Now chlorine atom has become Cl minus chloride ion. This is not stable, whereas this is stable. Their outermost orbit is not completely filled, so it gained 1 electron and became stable. This is how, if you want to clearly explain, this is the best picture to explain you that. Chlorine gained electron, became chloride. Chlorine is neutral atom, whereas chloride ion is negatively charged particle. Right? Now, if you compare the aluminium and the chlorine, aluminium is donating or giving off, transferring 3 electrons, but whereas chlorine, it is taking only 1 electron. Now here the logic lies. So when 1 aluminium atom is giving 3 electrons, then 3 chlorine atoms go and take 1 each. 1 chlorine can take only 1 electron. If 3 chlorines goes there, if 3 chlorine atom goes there, everyone will be taking 1, 1, 1. So they are taking 1 electron each donated by aluminium. That is what the secret here is. 3 chlorine atoms will be taking 3 electrons and become 3 chlorides. 3 chlorine atoms will take 3 electrons transferred by the aluminium and becomes 3 chloride. That's what he says. 3 chlorine atoms gain 3 electrons and form 3 chloride ions. Now, aluminium Al3 plus is there, and here 3 chloride ions are there. Those are positive, these are negative. They are cations, these are anions. Right? We all know opposite charges attract each other. But please remember, aluminium is getting inert gas electronic configuration of neon, and chlorine is getting the inert gas electronic configuration of argon. But their outermost orbit is getting completely filled. Now they are becoming stable. That's what he says. Aluminium atom transfers 1 electron each to 3 chlorine atoms. Fine. Next, aluminium loses electron to become stable like inert neon, and chlorine gains electron and becomes stable like near. Right. Chlorine is becoming like argon. That's the truth. It's like argon. Now, aluminium, which is nothing but cation, and the 3 chlorines, which are nothing but anion, because of the electrostatic force of attraction, they combine to form aluminium trichloride. That's what he says. Hydride is formed by electrostatic force of attraction between Al3 plus and 3Cl minus. This is how we can go with the example of aluminium trichloride, which is an ionic bond. Hope you are able to. In this channel, I have been placing both math and science videos.